Hello everyone. Today we will present our topic, Bimetallic Mechanical Thermostat. Me and Boran, as members of the group, will cover what is thermostat and how it works in our talk. Let's begin with what is thermostat. Thermostat is a device which is used to maintain a desired temperature in a system, like refrigerator, air conditioner, iron, and in a number of devices. Modern word of thermostat based on two ancient Greek ones, thermo meaning heat and statos means standing, like status, stasis, and vice versa. We can just tell from its name that the thermostat is something that keeps heat the same. Let's continue with working principles. Thermostat works on the principle of thermal expansion of solid materials. Most things get bigger when they heat up and smaller when they cool down. Mechanical thermostat used the idea to switch an electric circuit on and off. The two most common types of use bimetallic strips and gas-filled bellows. We will present bimetallic strips used thermostat. A traditional thermostat has two pieces of different metals bolted together to form what's called the bimetallic strip. The strip works as a bridge in an electric circuit connected to our heating system. Normally, the bridge is down, the strip carries electricity through all the circuit, and the heating is on. When the strip gets hot, one of the metals expands more than the other, so the whole strip bends very slightly. Eventually, it bends so much that it breaks open the circuit. The bridge is up, the electricity instantly switches off, the heating cuts out, and the room starts to cool. But then what happens? As the room cools, the strip cools too, and bends back to its original shape. Sooner or later, it snaps back into circuit and makes the electricity flow again. So the heating switches back on. By adjusting the temperature dial, you change the temperature at which the circuit switches on and off. Because it takes some time for the metal strip to expand and contract, the heating isn't constantly switching on and off every few seconds, which would be pointless, depending on how well insulated your home is and how cold it is outside. It might take an hour or more for the thermostat to switch back once it's switched off.
Dr. Ray Franco has compiled some excellent photos of bimetal strip thermostats that show how exactly how they work. This one is copper, this one is iron. They have different coefficients of expansion. This is unbounded form, this is bounded form, and this is grounded form. Some parts shown here. All of the metallic thermostat switches on and off. It enables you to set the temperature, this one, and connecting this one, and temperature sensor. Iron expands less than brass, and electricity flow.
Hi, my name is Burak Enes Öz. Today, me and my friend Emre Coşkun will talk about materials of the bimetallic thermostats. Bimetallic thermostats use two strips of a different metals to convert temperature into mechanical displacement. Different metals, which are often steel and copper or steel and brass, sometimes it can be iron or nickel, are joined together throughout their length and will expand at different rates as they are heated. Metals which are used in bimetallic thermostats are selected based on their coefficients of linear expansion. Therefore, the key point is the coefficient of the linear expansion. For instance, bimetallic strip made of brass and silver cannot be used in the thermostat, since they have a negligible difference in their thermal expansion property. You can see the pictures of steel, brass, and copper. Also, there is a picture of structure of the bimetallic strip.
Hi, my name is Emre and I will continue with the types of bimetallic strips. They are basically in two types. The first one is the spiral strip type. It consists of a spiral-like structure and a pointer is attached to it, which is used for scaling the temperature. When the spring structure is heated, then the metals exhibit thermal expansion property and it deforms where there is a fall in temperature. At this stage, the pointer records the temperature on the scale. These kinds of thermometers are usually used in recording ambient temperature. And this is the picture of spiral strip. The second type of strip is helical type. It consists of a helical-like structure whose operation is similar to the bimetallic strip, where the free end of the strip is connected to a pointer. Whenever the strip is heated, it experiences thermal expansion property and contracts on cooling. At this stage, the pointer records the temperature reading. Usually, these kinds of thermometers are used in industrial applications. And this is the structure of the helical strip.
Today, me and my friend Ege Berk are going to talk about market researching parts of the bimetallic mechanical thermostat. And we are going to start with the general information of the market researching of thermostat. Different companies are inventing on developments for better and smarter thermostats, which are more efficient and precise about the minute change in temperature. This developed a market for the bimetallic thermostats, and of course it is a price, and we are going to examine the cost and the reasons behind this price. This part we are going to talk about we're going to talk for answering these three questions: the average cost of the machine, most expensive version of the machine and the reason behind this price, and the main factor to the cost of this machine, like materials, transportation, or marketing and manufacturing. In average cost, a bimetallic thermostat costs £6 to £8 on average in United Kingdom market. But in North America, it's slightly cheaper because of the technological developments and the exchange rates that are better in Northern America. And there are leading companies which are operating in manufacturing of bimetallic thermostat, like the pioneers of this thermostat industry, Honeywell, Texas Instruments, Schneider, and Johnson Controls.
I'll talk about the main contribution to the cost of this machine. A bimetallic thermostat is used different kinds of industrial areas like electronics, automotive, healthcare. Its usage is widespread and it is used in technological devices like heaters, toast machines, oven, refrigerators, clothing irons, and so on. Since they are used in any kind of heating or cooling device, they are frequently demanded by the manufacturers of these devices. Bimetallic thermostats are small and as a result, they are easily transportable. So transportation is actually not a price changing factor. There are three kinds of bimetallic thermostats, which are high, medium, and low switch temperature thermostat. The prices differ by the type of thermostat. In a bimetallic thermostat, there is a bimetallic strip, which consists of two kinds of metals. These metals can be gold, silver, nickel, alloy, copper, brass, iron, steel, and so on. Difference in the prices are mainly determined by the type of the metals. The bimetallic thermostat gets more expensive when the metal gets more expensive.
We used SolidWorks for constructing bimetallic strip drawing and animation. At the beginning, we needed a simple 3D strip, which will allow us to see the effects of thermal expansion clearly. So we modeled a long and thin rod, which we can observe the output ideally. After saving this part, we used the strip twice and mated all the faces to make parts fully defined. In order to adjust coefficients of linear thermal expansion, we thought that we should pick two different metals with a distinction between their coefficient expansion. So we edited parts by changing the top part's material to copper and the bottom one to alloy steel. As a result, with the temperature rise, the top part, which is made by copper, will expand more due to higher coefficient expansion.
After that, in fixture section, we fixed the left faces so they couldn't move as we give heat to the system. For raising the temperature in external load section, we gave 300 Celsius to both two parts. After adjusting properties, we ran the study, which you can see that the copper material expands more than the alloy steel material. This expansion is being used for the production of bimetallic mechanical thermostats. This basic part permits the device to perform differently according to changing temperature.